There are four types of analytics. The lowest level is descriptive analytics. Next, there is diagnostic analysis, then predictive analytics, and the highest level is prescriptive analytics. The lowest level, descriptive analytics, starts by analyzing what is actually happening now. Consider an example where a mobile handset manufacturer wants to find out for which mobile there is more demand currently in market. In the next level, he wants to find out why it has happened. Maybe it is due to a good quality selfie camera installed in one particular model. Then in the next level, we can predict in future which kind of mobiles will have more demand. And the next highest level, it's the prescriptive analytics level where we can predict what should be done to improve the demand for one mobile device. So with the help of the large amount of data, we can take different types of decisions and which will improve our company's output. Next, I want to show you a slide which shows the importance of doing data analytics carefully. The slide is self-explanatory. You can read this. Okay, we are moving on to the structure of big data. There are three types of data: structured, semi-structured, and unstructured. The traditional data sources are structured data. It will be in the form of a table. All the columns will have headers, and we will arrange the data in the forms of rows in it. But coming to semi-structured data, it will be partially organized. Examples for semi-structured data are spreadsheets, XML, etc. If you take a spreadsheet, in one sheet the data may be structured. But when we combine the different data arranged in different sheets, all this data in different sheets may not have the same structure. But we will have to take collective data from these different sheets. So it's only partially structured. So we call it a semi-structured data. The next type of data is unstructured data, where the data will not have any particular structure. The examples are the emails that we receive, the Word files in our system, the social media posts, audio and video data that we come across. These are all examples of unstructured data. We have mechanism to handle these different types of data. Okay, next let us see why big data is important. It's because it can introduce dramatic cost reductions, improvement in time required to take decisions, and we have already seen that companies like Google, eBay, LinkedIn, Facebook, etc. are built mainly around big data. Next, we'll see how big data is different. Big data is different due to many reasons. First one, the data is automatically generated by machine. Let's see the next slide where it shows the sources of data. In addition to the users, data can be generated from different applications, systems, IoT sensors, etc. So there are many sources of data, and it contributes to the large volume of data that's being generated. And so this data is coming from entirely new sources of data. An example is internet. Through internet we share data and it multiplies. And big data is not designed to be friendly. As we have already seen, the traditional data management tools cannot handle data like text streams. Sometimes the data may not have much values also. We need to focus on the important part. You can see examples in social media posts. There may be many posts and many of them will not have any value. We need to focus on the important part. Let's move on to the next slide. The types of tools used in big data. The tools used in big data depends on the different parameters: where processing is hosted, where data is stored, what the programming model is, how data is stored and indexed, and what operations are to be performed on the data. These are some list of tools used in big data: Python, R, Hadoop. Statistical tools for our data analytics are SAS, SPSS, etc. In this course, we will learn Python, R, and Hadoop. Next slide shows the applications of big data analytics. They are smarter healthcare, homeland security, traffic control, manufacturing, multi-channel sales, telecom, trading analytics, search quality improvement, etc. You see this diagram where the data is captured up to this point. We want to predict the future structure of this data. Looking at this diagram, it's very easy to predict the future data, and it will be like this. So visualizations will help you to do the future predictions very easily. And see outlier identification. From this visual, you can easily identify the outliers. And you see the value creation by industrial internet. The data may be coming from different sources, but as we connect them together, that will give you more information, service, and value. This diagram shows the different views of an aircraft as a collection of sensors. Sensors are fixed in different parts of the airplane, and all these sensor created data will contribute to the large volume of data generated, and this data will help you to do many things, including doing predictive maintenance of the aeroplane. Next, let us move on to the risk of big data. When we are given with large amount of data, we don't know what to do with it. We need the right people to solve the right problems. The data should be given only to the right people, otherwise there will be problems. And as the size of data increases, the processing and analytics required to get information increases, and thereby costs escalate too fast. There are many sources of big data and it may cause privacy problems. And this is another joke. You can read it. Next, we want to analyze the role of a data analyst and data scientist. The duty of a data analyst is to find out what is actually happening now. But for a data scientist, higher levels of analytics will be required, like predicting what will happen in the future. And you can go through their different items in this slide. Another important fact is that the data is being generated very fast. And you can see that the 90% of the data in the world that you see today has been created in the past 2 years. So that's the speed with which the data is being generated. Okay, this is another joke. And finally, moving on to the challenges of big data. If you want to become a data analyst or a scientist, you need to do many things, starting from capture of data, curation or cleaning of the data, then doing data analysis, searching for the right information, sharing the data to the suitable people, managing the storage, transfer it, visualization, querying it, managing the information privacy. These are the challenges to be handled by a data analyst and a data scientist. And this is the concluding slide. Data volumes will continue to grow. Ways to analyze data will improve. More tools for analysis will emerge. Prescriptive analytics will be built into business analytics software. Real-time streaming insights into data will be the hallmarks of data winners. Machine learning is a top strategic trend now. More companies will appoint a chief data officer aimed to solve new problems or old problems in a better way. With that, I am concluding the introduction session on big data, and you have seen that we need to study a lot about big data. Our course will focus on the tools used for doing data analytics. They are R, Hadoop and Python. Wish you all the best.